Now, welcome. Here with me I have a question under calculus 2 that states that find the integration, or that is integral of sine x cos 5x dx by substitution. So the question is find the integral of sine x cos x, that is raised to 5 x dx. The method is by substitution. So you need to be using only substitution method, but not any other method. Now, how can you perform this? So your step number 1 here should be, you are supposed to let cos x, remember it is cos 5x, so just let cos x to be u. Thereby you will come up here with a solution here. So the first solution I've just said that you let cos x to be u there, so it will be let cos x be u. Now when I substitute it here, it will be integration sign, that is sine x u raised to 5, you get, then I have now dx. So that first method is very important as well. Now after that, you are now supposed to use now substitution. How will I substitute? Remember I've said that let cos x be u, and therefore when I find du dx, then I rearrange it in a manner that I have dx is equals to something du. That's what I'll be substituting here in dx here. So instead of me having dx, I'll be replacing it with that value on du. And therefore, how will I perform that? That one marks the second step that states that you are supposed to be getting du dx here. So when you have cos x, to get du dx, you are supposed to differentiate the cos x. Now when you differentiate cos x, actually is just negative sine x. My main aim was not only to reach here, but to get dx on one side, and therefore I can as well cross multiply here to remain with du, which is this. Du is equals to negative sine x dx. So that is negative sine x dx. But I want this dx, and therefore I'll divide by negative sine x, divide by negative sine x. So I'll come here, divide by negative sine x, divide by negative sine x, such that this one goes, then I remain with dx is equals to du over negative sine x. So that's what I write. So dx finally is equals to du over negative sine x. Now the main reason why it is being called substitution method is from here. Now remember here I was having dx, and already I've gotten dx to be du over negative sine x. So your work is to substitute where dx is, just substitute it with du over negative sine x. That is it. So I'll come here and say that one is equals to the integral, that is sine x u raised to 5 there dx, and my dx is du over negative sine x. So we will come here and say that is du, it is better to write dot there to mean multiplication, over negative sine x. So that is negative sine x. Now when you look at this sine x goes with that sine x to remain with a negative there. So when you multiply that negative with a u raised to 5, it will be, that is negative u raised to 5 du, and remember to put that sign. Now this sign means integration, so it is very easy now to integrate u raised to 5 du by so saying that you are supposed to add 1 to the power. After adding 1 to the power here, you divide by the result. So when the power is 5, so 5 plus 1 is 6. I'm supposed to divide by 6 as well. So you will come and say it is negative u raised to 6, because 5 plus 1, which is 6, over the result, that is 6 here, plus a constant c. Now after this, remember back here I said that let cos x to be equals to u, and here I have u, meaning when I substitute cos that is u with cos x, I'll just be correct, and therefore I'll just come and say it is negative 1 over 6, because this one can be written 1 over 6, that is u, and u is cos x, so it will be cos x, but it is raised to 6. Remember, u was raised to 6 there. Then you ensure that you add a constant c. Now after this, you can simplify this bracket here by so saying that it is now negative 1 over 6 cos, this 6 now will mean you will just say cos raised to 6x. So I'll come here and say raised to 6x plus a constant c. After reaching here, you shall have gotten the integral of what the question wanted using substitution, and therefore you will have reached the final answer here, making you to be correct. Otherwise, let me see you in the next class. Bye.